So welcome to one more session on frontiers in CFD. Today we are going to see how the floating point exception error can be avoided from the given conventional heat pipe. So first of all, starting the setup file. So actually the error has occurred in this particular simulation and it was not able to resolve the error with changing the time step also. So we'll show the live case of this conventional heat pipe, how the floating point exception error can be avoided using this. So first of all, edit. As you can see the setup file which has been available here. So we have opened this. So last time in the one of the earlier video we have seen that you can reduce the time step and you can avoid the problem of floating point exception error. But let's understand a situation where you cannot reduce the time step. So let's start with the 4 and check it out. Okay, so first started with 4. Let's see if there is any error which is coming out. So it is okay. So we have floating point exception error. So what was the thing? We'll just check it out. It shows floating point exception error. The value of current number is greater than 250. Global current number is 250. You can see the time step there are 999. So last time in the one of the earlier video we were shown we can reduce the time step, but the time steps are quite less here. Say if I go with I will close this without saving and open with the same again, and instead of providing 4 okay, I will just close this also. I will say it is no. One more time I will open and will check how it will proceed. So last time it was 4 uh, time steps which were specified. Now I will specify 1 and we'll check out whether it is able to solve it or not. So last time with the 4 also it was showing an error. So one more time open this. So if such problem occurs where we cannot reduce the time step and still we want to continue with the simulation, uh, what process we need to follow in order to proceed further? So let's make it okay. So instead of specifying 4 I will specify 1. Okay, now I specified 1. I will check it out whether it is able to solve it for us or not. Okay, you can see in the residual this is going up, so that means there is a problem. Okay, one more time I will run this. So see here it is a floating point exception error again. So I have specified only 1 and still it is showing 1 error. So let's make it this one and try one more time. Now we cannot take the time step as 0.5. Okay, so this is the difficulty, and so we say even if it shows error at 1, then it will be difficult to continue with the process which we have followed in one of the earlier case where we used to take smaller time step and proceed further. So this step will not work out over here. So in order to overcome this, what steps need to be followed, so that I will show you. when we are running such kind of simulation. So I will go back to my workbench window. In that workbench window, I will go with the mesh option. I have opened the mesh option available. Now I'm going to change the size of the mesh. Earlier the mesh size was different. Now I'm going to change the size of mesh. So I will not keep the mesh size as the one which was earlier, because even if I are trying to have different time steps, still it was showing error. So what I will need to do is I will change the size of mesh which has been available here. So instead of 0.021, I will make it 0.05. So mesh, it has been generated on your object. You can see the size is 0.05. I will make it update and then I will proceed. So in such situation, what will happen is you might need to start the process again. So that is one of the difficulty when we are running such kind of we can say we are doing some, or we are modifying the mesh. So in that case we have to start the process again. So let's go back to your here. Now you can see it was a floating point exception error which has come at triple, I guess, 999 as a timestamp. Okay, so it has come at 999 timestamp. So what I will do is I have changed the mesh size, and accordingly now I will start the process again. So let's make it update and go back to your workbench window, and you will be observing one option which is there, which is called as update project. So I will click on this update project. So accordingly what will happen, the mesh which we have changed, accordingly the project will start updating. So we are not changing any kind of boundary condition. The boundary conditions will remain the same. Only thing what will happen, we have changed the mesh size, and accordingly these things in the setup will go on to change. So it is asking available material properties have changed. Please confirm the property values before continuing. So you have to make it okay uh, over here, and you can see the process has started again. So we have started it again from 0. Over here you can see uh, earlier it was the error occur at 9, we can say the time 999. We have started this process again. So we have started it from 0. So I will again specify some let's say 100 times step, and we'll start will one more time perform the iteration. So click on calculate and start proceed. So one of the difficulty with the method which you have followed right now is that whatever the time step or iterations you have performed earlier uh, will miss out that iteration, and the process will again start from 0. So this is one we can say drawback with this particular method. But still we can say in the if you observed at the start, we are not able to continue with the iteration because of the problem of current number. Even if you take 1 as a time step, it was showing the error, and that's why we have to go back and change the mesh size the way we have done here, and accordingly we can still follow with the same process. But one thing which has to be remembered is we have changed the mesh size, and with this change in the mesh size we are trying to run the simulation. So if last time it was error occurred at 999 as a time step over here, so we'll just check whether the same problem occurs or not. And we say one thing which you might have observed is we have taken the smaller quite fine mesh size earlier, and because of which the time required was quite more. Here the time has been considerably reduced. You can see the process of iteration is quite fast. As at the same time, you can at the top of this you can see the the simulation. It also shows some yellowish part, so that indicates your liquid has been started to moving up. It has been transformed into vapor. So this is how the process is. So we are taken it 100. I will just try to show you with the help of 999 as a time save whether the same problem occurs or not. So this method is particularly suitable. So if preferably what you should do is you should take the smaller time step if possible. If we are not getting any kind of problem of floating point exception error, you should always try first for smaller time step, and then you should follow the method which we are specified right now, because unnecessarily you might be losing some time in performing the iteration which we had done earlier. So this is an alternative method which can be used to avoid the problem of floating point exception error. So you can see at the top, yeah, the variations are can be observed in at the top of your image. So we'll quickly cover this one, and we'll wait till the, say, 999 iterations are being performed. If we say that time we are not getting error, it is likely that it will be able to will be able to solve this particular simulation with, we can say, without having any kind of errors. So you might be in position to visualize the entire things. Again, we cannot 100% sure that there will not be any problem of current number in this particular case, but if some problem occurs, you can, we can say, try out few alternative methods which we have done earlier, like taking a smaller time step, and then just follow it for some duration of time, some duration of time step, and then again take out higher value of time step. So this is how the things that can be done to avoid the problem of floating point exception error. So we have completed 1099 iterations. Here you can see the process has started. Uh, we haven't received any kind of error. I will just make it, say, 100, and I'll check out whether there is any floating point exception error or not. So right now there is no such error, and we can see, you can see the process of iteration is going on. So if you encounter in some situation where you cannot change the, we can say, time step, so in that situation the better way is to go back to your mesh, change the mesh size, and accordingly again make update the project. So where is the option of update? Update is the option is here. So once you change the mesh, click on the update, and the process will start automatically without applying the boundary condition. Means without, you don't need to enter again the boundary conditions. So whatever the boundary conditions which was provided earlier, it will remains as it is. Only thing what is going to change is the size of mesh which you have done. So this is the best way to prevent the time which is required for simulation, because again you cannot go and start from zero for the process. So it's the best way is just to change the size of mesh and go back to the workbench window and click on update option. But one more thing that has to be remember is this process, the iteration will start again from lower value, means zero. So we say this is one drawback of the system, but again, if there is no such option available, then by this then such process can be utilized. So this is how the things which are there when we are having the floating point exception error. So the error can be avoided by changing the mesh size with the, if with the help of the mesh option available. Take a different mesh size which was earlier. Again, the time required, if we are taking a mesh which is not too fine, the time required will be less for the performing the iterations. So this is how the things which can be run. We'll just check how long it can. Okay, we'll complete this particular time steps, 100 time steps, and we'll check out how the simulation which will play the simulation based upon this. So you can see some here the process which shows the formation, as well as here you can see the vapors are being formed. They are trying to move towards the condenser section, towards the top. So 44 time steps are been remaining. we can see this through the animation. You can play the simulation just to visualize how we can say the flow patterns are been there. It may not be that properly visible over here. That will be best visible in the post processor, but still you can get an idea how the the process of evaporation and condensation has been taking place. So this is just for better visualization, and during the while performing the iteration, whether the liquid vapor salts are moving away, moving away from the evaporator or not. So you can just check it out the scale residual also. So if these parameters are the way which you are observing right now, if they are going in that way, there is not likely to have any kind of we can say error, which is like floating point exception error. But if you see this yellow and black, they are coming nearer to each other, or these are coming quite nearer, then probably there will be chances of having the problem of floating point exception error. So with the help of residual also, you can predict also whether there will be a chances of floating point exception error. At the same time, you can always check out for the current number, which you can see in the console window, which is at the bottom. So that is also one way by which we can check out whether there will be a problem of current number or not, or there will be the problem of floating point exception error. So it is almost 16 time steps are been remaining. Once that has been completed, we'll see the animation file. So 4 are remaining, 3 are remaining, 2 are remaining. So around 1200, you can go to this playback and click on this, say 10, or you can take it 100 also, but it will be very fast. So that's why yeah, you can see here it is going up. So in this way you can visualize the flow pattern. So this is also going up. One more time, just carefully observe at the below portion. Yeah, here. So click on save button, and you can further continue with the simulation. So you can see there is 2,58,000 iterations are been performed. Still we haven't received any kind of floating point exception error. Till the time we have changed the mesh, we haven't received any kind of floating point exception error. You can see the simulation also, where you can have the vapors which are moving toward the top, and at the same time you are able to see these are the small vapor bubbles which are going towards the top. The visualization can be quite easy with this particular we say the mesh size. The simulation is going in the quite correct way. Ideally there will be a chances that there will be a problem of Coron number or floating point exception error. So it is likely to complete now around 13,000 times steps. So I will try to have this around 50,000 time step, and we'll check out how the visualization will take place. So that's it now from we say till the 13,000 time steps. 12,960 time steps has been completed. If you are able to see on the console window, so around an hour is required for somewhere around 1,000 time step. So the you can see enlarged image of this, and at this particular portion. This will be quite better visualization will be there in the post processor when we are moving to the next part. So right now easily it is going towards the 13 completion of 13,000 time steps. Don't forget to save the work once that has been completed, because we cannot predict when the problem can occur or when the problem of floating point exception error can occur. So as soon as you complete your the time steps, it is very important that you should go back to your workbench window, and while going to the workbench window, click on the save button which is when available. So the same process we are going to follow when you are specifying the number of time steps. Say for example, right now it is specified as 990. So whatever number of time step you will specify, always try to save the work in between. One more important thing is try to restart your computer in between, so that there will not be the bunch of files which are been there, because sometimes you might see your system becomes slow, so this can happen, and that's why when you save the work, sometimes you may always go for we can say we can say restart. So right now you can observe there is a smooth in one line it is moving. Sometimes people are observing some drops over here, so that means its system might not be able to handle, and in that case it will be better option to go and restart your computer. Again, that has to be remembered is all the things has to be saved, and then only you can proceed with that particular option. So I will just show you one thing, how many time steps we have completed. We have completed around 13,000 time steps. You can see this particular simulation also. We know we might not have much time steps to show the variation over here, but let's try to run with the 10. You might see these are going up over here, so uh, you might require more number of time steps in order to visualize in better way, and that will be quite better if you are going with the post processor option. So right now save the work, and one more time you start the process of calculation. So go back here, I will specify now it is 1000, and we'll continue with the calculations. Always observe the residual also in order to know whether there will be a problem or not. So that's it for this particular video. So we are around 6,50,000 230 iterations, around 32,000 time steps we have completed. So we are on the right way to for this complete simulation. I will just try to show you with how it is when there. You can see this portion where the vapors are moving up, at the same time the liquid is coming down. So this can be visualized over here. So around 32,000 time steps we have completed. Uh, we are trying to have around 50,000 time steps so as to visualize this in quite better way. More specifically, this will be visualized in post processor rather than what we are observing right now. So scale residual is going in the right way. We are not observing the problem of current number, though there was issue with the current number which has occurred, that is floating point exception error in between, but successfully we have tried to do with some changing time step, as well as you can say uh, closing all we can say the fluent setup, and then again try to proceed with the simulation. So now it is working correctly, and we are expecting that we are will reach to around 33,000 time steps quite near, and it will be around up to 50,000 time steps to visualize the things in better way.